welcome to the module. So now we will see circuit board. So this is our 2N3055 transistor. This is a temperature sensor and this is 741 IC. So general purpose operational amplifier. Now let me build the circuit what we have seen in our presentation. So keeping on our presentation, right. So when you look into the circuit, so if you recall the data sheet of 741 operational amplifier, so the second pin is nothing but your negative terminal, whereas the third pin of 741 is non-inverting terminal, whereas the fourth pin is minus VCC and seventh pin is plus VCC, and the output is nothing but sixth pin. So what I will be doing is that, so this is 180 ohm resistor. I will be connecting the output, which is nothing but sixth pin. So 4, 5, 6, the sixth pin with 180 ohm resistor to the base of transistor. So this is 1 ohm 5 watt resistor. This should be connected across the negative terminal and the ground. So the negative terminal in this case is second pin, and the ground here somewhere here I will be taking it and I will be connecting it here. Similarly, even the negative terminal of an operational amplifier has to be connected to the emitter of transistor. So when we look into the connections of 2N3055, pinouts of 2N3055, the casing act as a collector, whereas these two terminals act as base as well as an emitter. So in this case, the red wire, so we have 3 wires here. The red wire indicates the collector. So even here we can see this is a collector. In this case, the red wire act as a collector. So the red color wire, this act as a collector, whereas the black color wire act as base and the brown color wire act as emitter. So what I will be doing is that I will be connecting these 3 terminals to this, and in this case the black is base. So this will be connected to the base. Similarly, the brown is emitter. Emitter will be connected to the second terminal, which is negative, and the first one is a collector. So the collector will be connected to our power supply. Now similarly, the sensor require 5 volts. So when you look into the data sheet of LM35, the red one indicates the plus 5 volts, the black one indicates the ground, and the brown indicates our output. So I will be connecting with 3 male to male jumpers, red one with yellow, output with green, and black with output. And the outputs for this I will be using USB DAC. So when we look into our USB DAC pinouts, so 31st is 5 volts and 32 is ground. So what I will be doing is, red I will be connecting it to 31st, and the black I will be connecting it to ground. sensor. Now, so after connecting the power supply, required power supply to this, the output of this particular terminal has to be connected to analog input channel, in this case is I0. So what I will be doing is that the output side, which is nothing but green, I will be connecting it to this. So to the input we have to provide analog output. Okay, then let me connect this power supply. So we also have to provide plus 15 to operational amplifier and minus 15 as well. Along with this we require plus 15 to be provided to the collector of this. So what I will do is that I will, from the channel 1, the maximum voltage I will set to 12 volts, and the current, the maximum current I will set it to 2.5 amps. So that more than 2.5 amps the power supply will switches off. And similarly, even in case of channel 2, 12 volts I am setting, the current is 1.5 amps. When I press output, so both channels will supply the same amount of output. Yeah. So this is our channel 1, whereas this is our channel 2. So what I will be doing is that, so the 15 volts should be connected to the 7th terminal. Okay, and whereas this is our minus 15 terminal. So the plus 15 I am replacing with this wire, connecting it to plus 15, the VCC terminal of operational amplifier, whereas this is our ground. This ground I will be connecting it to this. So everything should have the same common ground. And similarly, even minus 15. So this is the positive terminal of that terminal. So in this case this acts as a ground, because since we have to provide minus, I will be connecting it. So everything is having a common ground right now. Similarly, we also require to connect the output, which is nothing but a 32nd pin, to be connected to the same ground. So what I will be taking is, I will take another wire. So in order to make everything as a common ground, I will be connecting it this here. Let me make the connections. So this is minus VCC, this I will connect it to the 4th pin. Similarly, we have to power LM35. So in this case it is required 5 volts. I will be connecting the yellow wire, which is 5 volts in this case, to this device. and the ground should be grounded here, same common ground, and output, which is brown in this case, has to be acquired using this particular pin. So now the connections to the sensor is done. So now if you see the connections, so what we have made, so we have realized our circuit, whatever we have seen, which is with operational amplifier as well as our 2N3055 on this breadboard, such that the base of a transistor is connected to the output of operational amplifier using this particular resistance 180 ohms. Now when you see that another terminal, which is the emitter in this case, so the emitter, when you see the emitter is connected to the second terminal, which is negative terminal. Along with this, the resistor 0.1 so 1 ohm 5 watt resistor is also connected across the negative terminal and the ground, and all grounds are connected, shorted, and as well as the output, the analog output from the which is generating from USB DAC is connected to the positive terminal of the operational amplifier, which is nothing but third terminal. Similarly, the power, the required power to the operational amplifier has is providing using this particular power supply. So this is channel 1 and this is channel 2. As of now I have not switched on the output, so that once I switch on the power, when I switch on, it provides 12 volts as well as minus 12 volts, and the power to the transistor is connected to LM35, which requires a 5 volts in order to operate, has been provided by using a USB DAC at the terminal pins of 31 and 32. And similarly, the input voltage which is being acquired by the operational amplifier, sorry, the sensor output voltage will be acquired using NI9207 CDAC, so which is connected at this particular point. So now all connections are made. So let me switch on. So this is right now the current flowing through this channel 1 is 24 milliamps. Now I have not still provided the output yet. Suppose if I collector, so it is drawing 1.8, just started heating. Okay. So when we look into the PC, so here we can see right now the set point is 26.43, so just make it as 25. Okay. So when I start running the system, the actual temperature right now it is showing as 20 degree. So this has been not connected yet. So this is our actual temperature. So when I run the program, right, so the actual temperature on top of the transistor is 30.81, whereas the set point is 25. So that's why the manipulated variable output is of minus volts. So when we provide a minus voltage to the driver circuit, which makes the system to be off. So when you look into the power supply, the current drawn will be as similar to the previous state, which is nothing but right now the system is in off condition. Now when I make the set point to 50, say, now we can see the manipulated variable has increased to somewhere around 0.33. So when you see the current drawn by the system is increased from 24 milliamps to somewhere around approximately 0.8 to 1 amp, keep on increasing. So as a result, when it comes very close to the set point, the current drawn by the system will also decrease. So here we can see from the graph, so the white one indicates the set point, whereas the red one indicates the actual output on top of the transistor. So the temperature on the transistor slowly increasing. So right now the temperature is at 44 degree, and the time it is required to take in order to reach to the set point entirely depends upon external environmental factors as well as what is the gain that we have set to the system. So, right now I controller gain as well as D controller gain in this case is 0, which means that the controller right now which is influencing the plant is a P controller. So, it is a P, it is working based upon the P controller. So, let me try to increase the gain to 0.025 excuse me. So, it started increasing. So, 50. Right. So, here we can clearly see that it is now it is trying to maintain the temperature on the plant is equivalent to the temperature of the set point, right. It will not even go beyond that within the range of plus or minus 2% to 5% of tolerances error band. Within that range it is trying to maintain the temperature on the plant to be of constant. Suppose if I further increase to 70 degree, now here we can see the temperature increased to 71 degree. So, the manipulated variable also changed. So, by drawing really high amount of current, so approximately of 2 amps of current, the sensor also the plant also heated to very high temperatures. So, we can see from power supply. So, it is drawing power and keep on varying. So, since the temperature actual temperature is higher than the set point temperature, the manipulated variable is of 0 right now. So, minus voltage which is nothing but 0, which means using external environment it has to cool. So, let me decrease to 40. So, the temperature, the actual temperature right now is at 57 degree, but the set temperature is 30, I will make it as 30 degree. So, by nature, since we do not have any forced convection, so by using a natural convection, heat has to be dissipated to the environment. So, it will start cooling it. So, as a result, once it reaches to 30 degrees, it will again try to maintain the same temperature. As long as it is the actual temperature is higher than the set point temperature, the manipulated variable will be in negative, which means that the system is in off condition right now. It is not providing any power to pass through the transistor. As a result, the system that means it is a 0 volts, which means that it will not heat the transistor. So, we can see that it is slowly decreasing. You can observe the response. let me change the set point to 35 degrees so that it will not take much of time just to understand. Now if you observe that when the set actual temperature is slowly reaching towards the set point, so just I will make it as 40. Now the temperature is 37 degree. So since the difference is little higher, it also pushes little energy and started heating. So here we can clearly see it started heating, and now again after reaching to the actual temperature value, it is trying to maintain the 40 degrees centigrade. You can see what is actual temperature here. So now the both the temperature the plant as well as set point, when you see the plant temperature, it is at 40 degree, whereas the required temperature is also 40 degree, both with almost approximately the same value even at output side. So with this we can understand the working of a P controller as well as implementation of the P controller using the data acquisition device as well as a LabVIEW. So this particular process is called software in loop. So this is called as software in loop because the software is acting as a controller, whereas a plant is externally connected, and these two things are interfaced using data acquisition. So that's why this is called software in loop. The software which is written in the LabVIEW programming will be in loop with the plant, so where the plant is sitting outside, right. So the similar way we can even implement the PI controller as well as PID controller. It is not necessary that the same PI controller and PID controller to be implemented for all the times in order to control. Even we can develop our own algorithm, say similar to that of fuzzy logic as well as neural network, and interface it to the real world signal in order to understand the working of any system or any algorithm using functionality of any system. So with this I will stop.